Flash swap in Uniswap V3 allows you to borrow tokens as long as you pay the token in the same transaction and with some fees. So in this video, I'll show you a simple example of Flash swap. We'll start by defining some interfaces. We'll borrow tokens, so we'll need an interface for ERC20. And then we also define an interface for Uniswap V3 pool contract. The functions that we'll call is token 0 and token 1 to get the address of the tokens. And to do a flash swap with the Uniswap V3 pool, we'll call the function called flash. This function takes in 4 parameters: recipient, this will be the address where the tokens are sent to, amount 0 and amount 1 are amount of tokens that we want to borrow, and any other data that we want to encode will go under data. We'll call this function flash from our contract called Uniswap V3 flash swap. And when we do this Uniswap V3 pool contract, we'll call into a specific function inside this contract. This function that Uniswap V3 pool will call back into is called Uniswap V3 flash callback. So this contract is going to call the function flash on Uniswap V3 pool contract. And inside this code, Uniswap V3 pool contract will call into a function called Uniswap V3 flash callback. This is where the tokens are borrowed. We'll execute some custom code, and at the end, we'll have to pay the amount that we borrowed plus the fees. So as a function input, it has 3 parameters. The fees that we'll need to pay for token 0 and token 1. These fees are calculated by the pool fee times the amount requested. So for example, if the Uniswap V3 pool contract's pool fee is 0.05%, then we'll have to pay 0.05% of the amount that we borrowed. And then this data will be the custom data that we specified when we call the function flash. The code that we'll need to implement for our contract is in 3 parts. Some initialization code inside the constructor, a function to initiate the flash swap, and a flash callback called by the Uniswap V3 pool contract. So let's start with the constructor. First, I'm going to declare some immutable state variables. We'll store Uniswap V3 pool contract. So I'll type I Uniswap V3 pool private immutable. I'll name this pool. And we also store token 0 and token 1. So say ERC20 private immutable token 0 and token 1. We'll initialize this inside the constructor. For the input of the constructor, we'll pass in the address of the pool. So say address underscore pool. And then inside here, we'll initialize the pool by saying pool is equal to I Uniswap V3 pool, pass in the address of the pool. Next, we'll get the address of token 0 and token 1. Say token 0 is equal to pool.token 0. This will return an address, so we'll cast this into ERC20. Then we'll do the same for token 1. Okay, so that completes the constructor. Next, let's move on to the function flash. This is the function that we'll call to initialize the flash swap. For the input, we'll pass in the amounts of token 0 and amount of token 1 to borrow. uint 256 amount 0 and uint 256 amount 1. And inside here, we'll call this function flash. So I'll copy this and then paste it here. So we'll call pool.flash. And for the recipient, this will be the address that receives the token. We'll send the token to this contract, so say address this, and amount of tokens to borrow comes from the input, amount 0 and amount 1. And lastly, data. This is any custom data that we want to pass over to this function, Uniswap V3 flash callback. For the data to pass, we'll create a struct, fill the data inside a struct, and then encode it as bytes. So I'll declare a struct called struct flash callback data. And inside here, we'll encode amount 0, uint 256, amount 0, and uint 256, amount 1. And the other thing that I'll encode is the address message sender that calls into this function, flash. I'll call this caller. And when we fill out this caller, this will be message sender. Okay, so over here, you'll say bytes memory data is equal to abi.encode. We'll encode flash callback data. For amount 0, we'll pass in amount 0 from input, amount 1 from input, and for the caller, we'll encode message.sender. The reason why we're encoding caller over here is so that when Uniswap V3 pool contract calls this function Uniswap V3 flash callback, inside here, we'll decode this data and know who called into the function called flash. And the same goes for amount 0 and amount 1. By encoding it here and then decoding it here, we know how much amount we borrowed. Okay, so that completes the function flash. We'll call the function flash and then call Uniswap V3 pull contract. To initiate the flash swap, we'll call the function flash. When we call this function, Uniswap V3 pull contract will call back into this function called Uniswap V3 flash callback. And inside here, we'll write our custom code, and we also have to pay for the amount that we borrow plus the fees. The first thing that we'll do is we'll make sure that only the pull contract can call into this function. So here, say require message.sender is equal to address of the pool with the error message not authorized. Next, we'll decode this data. So here I'll say flash callback data memory decoded is equal to abi.decode. Decode the data from input and decode it as flash callback data struct. The next part is that we'll write our custom code here, right? Custom code here. And at the end, we'll have to repay the borrowed amount plus the fees. For this example, we'll keep it simple, and for the custom code, we'll just ask this caller over here to pay for the flash swap fee. So here, I'll say if fee 0 is greater than 0, then we'll transfer fee 0 from the caller over to this contract. Say token 0.transfer from decoded.caller to address this for the amount fee 0. Then we'll do the same for fee 1. Fee 1, token 1, transfer from caller to this contract for the amount fee 1. So we'll keep this custom code simple. But if you wanted to do an arbitrage, then you will write your custom code inside here. Okay, the last part is to repay Uniswap V3 pull contract. So say if fee 0 is greater than 0, then token 0.transfer to address of the pool for the amount. Amount will be stored inside this struct. So remember over here that we decoded the amount that we borrowed for token 0 and token 1. So over here, say decoded dot amount 0 plus fee 0. And we'll do something similar for token 1. If fee 1 is greater than 0, transfer token 1 for the amount, decoded amount 1 plus fee 1. Okay, and that completes the contract for our Uniswap V3 flash swap. Let's try compiling this contract. Inside my terminal, I'll type forge build. Okay, our contract compiled. Let's now try running the test. So I created a simple test to do a flash swap from the DAI WEF pool contract. In this pool, token 0 is DAI and token 1 is WEF. We'll borrow 1 million DAI from the pool contract. So over here, I call the function flash for 1 million DAI. And we'll need to pay for the flash swap fee. So for this example, I've used Foundry's cheat code to give this user 1 million DAI. And this user has approved the flash swap contract to be able to spend infinite amount of DAI. When this user calls the function flash on the contract Uniswap V3 flash swap, it's going to initiate a flash swap and then borrow 1 million DAI from Uniswap V3 pool contract, and this user will pay for the flash swap fee. Okay, to execute the test, I'll first initialize a fork URL environment variable and then type forge test -- fork URL match path test Uniswap V3 flash swap.test.sol and then -bbb. Okay, and our test passed. So we borrowed 1 million DAI and the user had to pay this much amount in flash swap fee. Let's check how much this is. I'll open a Python shell, paste the number, and then divide this number by 118. And it comes out to be 3,000. For borrowing 1 million DAI, this user had to pay 3,000 DAI.